Hey guys, this is Jimmy Kometz here with OCV Control Valves. I'm here to talk to you about solenoid control valves. Um, to start off, I work at OCV's engineering department. I work with Shirley Nelson in our sales department, and we mainly handle a lot of petroleum applications where you're flowing gasoline, jet fuel, or any number of other fluids other than water that might pass through our control valve. So let's get going. So a solenoid control valve is basically a pilot that is turned on or off based off of electrical signals that are sent to it. So this solenoid here, this is the windings of the coil, this green part here, and there's no power to those windings. So there's no magnetic field, in which case the solenoid is going to go to its natural state. Here we're looking at a normally closed solenoid pilot. So the spring is going to make the pilot close and not allow any fluid flow through the pilot. So here we have the coil has been energized, and in this case it is the magnetic field in the windings of the coil of the solenoid are actually drawing up this magnetic stainless steel core tube, and when that pulls that up, it's going to actually pull the pilot up off of its seat and allow fluid flow. So this is an example of an energized to open application. So we put that on our control valve, a very simple on-off solenoid valve. And when we send a signal to the solenoid pilot, the golden rule for OCV control valves is what this pilot here does, most times the main valve is going to do and mimic. So this solenoid pilot is open, energized. The main valve is just going to copy that, and it's going to open just the same. So before we get into some of the control valve models, I'll touch on the common application we see, and that is for loading into a reservoir of some kind, typically a truck, or you're loading into a truck or coming out of a truck with fuel. But all the same, it's going to be much like you would see at a gas station when you're putting fuel in the tank of your in the tank of your vehicle. So basically you're going to fill that reservoir quickly. You want to get that fuel in there fast so you can get on your way, and then you're going to get towards the end, and typically you can usually feel that it kind of slows down to a slower flow rate at the end of your load so you don't just spill out of your gas tank. So that's going to go into the first stage of closure. And then it basically slow fills until you top off, and then it's going to shut the device off completely. So that's the system that we're kind of talking about, and we kind of do that on a more industrial scale, larger scale, where we're flowing through 3-inch, 4-inch, 6-inch diameter valves to load into a system. So the first valve that we're going to start with is our Model 115.3 digital control valve, also known as a set-stop valve in industry. This is actually what I like to call our smart control valve. And it's actually controlled by other devices in the fueling industry, other PLC devices that are able to receive a flow signal from a flow meter in the system, and then take that flow signal and send an output to our control valve. And it's able to actively operate the two solenoids that are on the outside of the valve to position the main valve where it needs to be, basically to get the flow rate for the filling rate that is needed at the time while they're filling the reservoir. It's a very common valve that we sell for loading applications. So another type of preset load valve is our Model 115.25. It's a very simple configuration with two solenoids on it. One solenoid that is controlling your main valve, and one solenoid that is this solenoid here, and one solenoid that is actually on a bypass. So at the beginning of your load, your high flow solenoid here is going to open, and that is going to open your 3 or 4-inch valve and fill the reservoir quickly. And then once it gets to the end of filling the reservoir, or near the end I should say, it's going to de-energize the solenoid and it's going to close your large valve, and then it will actually energize the bypass solenoid. This is a solenoid with typically about 5/8 of an inch orifice, so it should allow about 15 GPM depending on the pressures in the system. through that bypass. We don't typically go larger than 4-inch valves just because that dwell flow, that flow at the end of your load is, if you go to a 6-inch meter, typically that flow rate will be too low to accurately read through your meter. So very similar to the 11525 is our 115.5S model. So this model has the advantage of being able to adjust your low flow settings. So you don't have your bypass around the control valve itself. You're actually using your main valve, your 3-inch or your 4-inch valve, to give yourself a high flow rate and also to give yourself the low flow rate. So you can actually adjust this collar up and down to set that low flow. That is the advantage of it, that you can adjust your low flow setting. The disadvantage is it does add a little bit of cost to add that limit switch onto the valve. So in either case, with your bypass solenoid or with your limit switch 115.5S model, you can add in hydraulic functions so that when you are loading, you're controlling either the flow rate into your reservoir or you're controlling the pressure as you're filling into your reservoir, whatever that may be. So just to wrap up, there are quite a few solenoid applications out there. We started with the single solenoid block valve. That is a very common application. We can also get into function activation, where we're using a solenoid to activate one of the many hydraulic functions that we offer. Pressure reducing, pressure relief, differential control, water slug valves for that operate on the discharge side of a filter separator. So, I mean, you can activate these functions with the solenoid to turn that function on and then de-energize the solenoid and the valve will just go closed. And then, of course, the loading control valves, where we were talking about our digital control valve, the model 115.3, and then the load sequencing valves like the 115.5S and the 115.25. So thank you guys for listening to my presentation. If you need anything else or if you need more information, you can feel free to go to our website at controlvalves.com. And if you have specific questions, you can contact our office and ask for me, Jimmy Kometz, or Shirley Nelson in our sales department, and we will try to get you an answer as quick as we can. Have a nice day. Bye.